So this part of the lesson, we talk about truth tables. So the bigger title, truth tables, equivalent statements, and then tautologies. These are brand new. This is a brand new term for you. But today I'm going to just focus on truth tables. Okay. So truth table, basically, what we do is that we make a standard table. We make a standard truth table, which is based on how many statements are there, right? So if there's two basic statements or two simple statements, then there's going to be two statements or two there's going to be two information pieces that we're going to be talking about, right? So if a statement has two simple statements, so then if a compound statement has two simple statements, then we make a table with 4 rows. And how does this 4 come? Because 2 raised to the 2 is 4. So we always do 2 raised to the number of simple statements. So let's say if you have P is a statement, Q is a statement, so we make the number of rows 4 rows there. And so this could be true, it could be true, false, it could be false, true, or it could be false, false. Okay, so that's how we figure out the 2 raised to the n, whereas n is a number of simple statements. In this case, it's 2, so 2 raised to the 2 is 4. Now let's do a proper example where we kind of talk about all this. So the question is, construct a table for not, in parentheses, not P or Q, and the whole thing is with the disjunction or Q. And after we made the truth table, or we make the truth table, then we use it to figure out something. So after we figure out the truth table, or we make the truth table, we use it to determine the truth value of negation or not, parentheses, not P or Q or Q. So, and it tells us that, okay, the instance is that P is true and Q is false. And we have to, based on that, we have to figure out the value of the given symbol, okay? So let's see how that's done. So what we do is we start with the basic table or the standard table. So because there are two simple statements, we're going to have 2 raised to the 2, which is 4 rows, right? So we start with that. Okay. P, Q, and then we also we put a negation of P, which is false in the first one. If this is true, then the negation of true is false. If it is false, the negation of false is true. Okay. So once we are done with that, then we're going to go to the next step. If you see our symbol, so we're going to use the truth value that we got for the not P, and then we're going to find the truth value of the Q, and then we're going to combine those two columns to produce another column and we're going to write the truth value of not P or Q. So not P or Q, that means if you have doing the disjunction of the last two columns, so because it's disjunction, if one of them is true, it's going to be true. Okay? And then we're going to move on to negating the truth value. So whatever we got, we negate that. Okay? So we're going to negate the not P or Q to produce another column. So negation means we're going to now make it opposite of what it is. So the true is going to become a false. The false is going to become a true. The true is going to become false in that way. So, and then we continue our last step here. We're going to form the disjunction, which is the OR of the not P or Q, which is the last column, the purple one that we have, with the Q. All right, and replace it in our last column there. All right, so we place that there. Disjunction of the purple and the second blue. And again, it's disjunction, so even if one of them is true, it's going to be true. So the first one is true, second is true, and the last one is both false, it's going to be false. Okay, so our last, second part of this was that when P is true, so if P is true and Q is false, then what happens to the answer? So when P is true and Q is false, it's going to be the second row, right? Which is going to be, the answer is going to be true. Okay, we see that, right? If the first column is true and the second column is false, then the last column is also true. All right? So it's all about truth value in this section. So the compound statements that involve exactly three simple statements. So if you have three simple statements, that will be 2 raised to the 3. So that's going to have 8. It's going to have 8 rows. So it's always 2 raised to the number, right? 2 raised to the number of statements. So 2 raised to the 3, which is 8. So we have to do different combinations of the true and false, and we can get the number of rows, which is 8. So true, true, false, or true, true, true. These are the different combinations of the true, false, and all that. So there's also another method that they use. We're going to try explain. If the given statement has n simple statements, So first we start, and we have n simple statements. So we're going to have 2 raised to the n rows. That's the same rule. Then we enter the truth value of each simple statement and their negations. All right. So we're going to use the truth value of each simple statement and their negations to enter the truth values under each connective within a pair of grouping symbols. It's if they're nested, then we always go inside out. So it always goes from left to right. Truth value. So this gets very complicated, but when you do the example, that will not be very difficult. So, but you still have to like try and see how it works. And again, if you have questions, you can ask me next week. If you guys need extra time, I'll give you extra time for this one, okay? The homework. But remember, it is very complicated, especially the explanation, the way it's explained here. So the last assigned truth value, that's the answer. So this one is construct the truth value for P, disjunction, negation of parentheses, P conjunction, not Q. So you have two simple statements. Remember, we start inside out. So we're going to make the basic truth table. And then okay, so 16 bit is going to be the answer. Again, this needs a lot of practice here. Okay. All right. And we'll just do in our live lesson or the Jamboard lesson. We'll practice there. Okay.